why students find organic chemistry challenging and how to fix it. Mistake 1 is doing as many questions as possible instead of learning the instructions. A lot of students think organic chemistry success is doing 200 practice problems. But Ochem doesn't work like math. The exam questions can be infinitely broad, and the professor can change the setup of the question just slightly, and suddenly you've never seen that question before. Students rely on patterns they see in the questions instead of learning the actual instructions, the logic, and the step-by-step guidelines that tell you how to think. The solution would be, before touching the practice questions, you need a clear step-by-step guideline for the topic. The concepts, not pattern recognition, the common exceptions, and how to identify them. And then you apply all of this to practice questions. Learn the rules from the right instructor, understand them, and then practice. An Ochem example would be, students memorize Markov's addition is the hydrogen goes to the carbon with more hydrogens. Then on the exam, the professor gives a rearrangement case or a resonance stabilized carbocation, and suddenly Markov doesn't work anymore. Those who only memorize patterns freeze. Those who learn why carbocations form and why stability matters know exactly what to do. Mistake 2, trying to rationalize the answer key. Many students look at the answer key and think, okay, that must be the reason. And then they make up reasons that sound right but are chemically wrong. Or even worse, they ask classmates or discussion boards, and the explanations are often oversimplified, missing the key steps, and actually incorrect. This leads to total disaster because one wrong rule can ruin half of the course. The solution would be never learn organic chemistry backwards from the answer. Ask your questions from someone who can break down the exact rule, can explain what not to do, note exceptions, and can tell you why something happens, not just what happens. An Ochem example would be a student sees an answer key showing E1 is formed instead of SN1. They say maybe substitution cannot happen here because the nucleophile wasn't strong enough. But the statement can be true or false depending on the solvent, temperature, stability of the carbocation, and competing reactions. So now they think they've learned something correctly, but actually they learned the wrong thing. A tutor can explain the real reason, carbocation stability, and heat favoring elimination. That's why E happened. Mistake 3 is not realizing Ochem is cumulative like no other first year or second year courses. Ochem stacks on itself more aggressively than any other science course than you ever take in first year or second year. In most classes, you can forget chapter 1 once you finish the midterm. But in Ochem, chapter 1 follows you to the final. If you have a gap early on, every topic after becomes harder because everything is connected. To understand just SN1, you must already know Lyman drawing, hormone charges, resonance, acid-base strength, nucleophilicity and basicity, stereochemistry, RNS configuration, carbocation stability, solvent effects. Miss one of these and new topics stop making sense. The solution would be treat Ochem like building a house. If the foundation is weak, the entire structure collapses. Every time you start a new topic, ask yourself, what earlier skills is required for this? If the skill isn't strong, review it immediately. Don't build new knowledge on a shaky base. An Ochem example would be a student is trying to do an SN1 or SN2 question, but never mastered formal charges or acid-base theory. They see a protein in alcohol and don't recognize why it became a good leaving group. So every substitution feels random and impossible to memorize. Mistake number 4 is memorizing reactions instead of understanding the mechanism. Many Ochem 1 students memorize flashcards like NaOH does this, HBr does that, cold KMnO4 gives this product, but in the exam, professor tweaks one small detail and maybe they change the solvent, temperature, or concentrations, and now the memorization rules fall apart. The solution would be stop memorizing reactions. Start understanding which species is the nucleophile, which one is the electrophile, where the electrons move, what determines the stability, why a reagent behaves the way it does, and if you know the mechanism, the product makes sense even if the question is actually unfamiliar. An Ochem example would be, students memorize H-verb adds Markinov across an alkene, but professor loves to ask, what if peroxide is present? Students who memorize one reaction panic. Students who understand the radical versus ionic mechanisms and why radicals flip regiochemistry get it correctly instantly, even though they have never seen this before. And this is why organic chem is my favorite subject to teach. Most students come in with low confidence and expect Ochem to be the killer course. But once they follow the right approach, understanding the concepts, learning the correct guidelines, knowing the exceptions, and practicing with intentions, something amazing happens. They start enjoying it. They start seeing the logic. They do way better than expected. Many of my students end up telling me that they actually like Ochem more than physical chem, something they never thought they would say. Because with the right strategy, Ochem starts making sense. It doesn't have to be a nightmare. It becomes a language you can finally speak fluently.